Good day. Today I'm going to be discussing Chapter 15, Data Visualization, using Matplotlib. And Aiden's going to be navigating my session today.
Hello.
So, let's begin. So, my first two modules are not related to this random walk um, module in class. So, I'll first discuss that. So, basically, firstly, we basically just downloaded or installed matplotlib, right, using the terminal, and then after that importing matplotlib, importing pyplot, and setting it to plt using alias. So for this first activity, just saying that you must plot the first 5 cubic numbers and then plot the first 5,000 cubic numbers. So in order to do that, firstly we have this list over here, this x value small, which basically has the numbers from 1 to 5, right? That would be the x values. And then this list here, y values, has basically this x double asterisk 3. What this does is basically creates a cubic number. And how that works is using this for loop, it loops through all the x values over here and creates cubic numbers with all those x values. So the final result will be displayed on your y-axis basically. So then we have here plt.style.use, and we set this style name here Seaborn, so it'll just style the graph. And then we have here the figure axis, and basically plt.subplots calls the subplots method, and that basically just like creates the graph for the x and y values. And basically we use the scatter method to create a scatter graph, right? And within the parentheses we pass the x values list and the y values as well, and then we set the basically the line to red, and then the size as well. Then basically just setting the title, the label for the x value, and the label for the y value as well. And putting the names of the labels and the titles and the font sizes. And then over here we're just setting the size of the tick labels, and then we use plt.show to display the the whole scatter graph. So if I run the terminal, this will basically be displayed here, as you can see. So this creates the scatter graph with the y values and the x values here, and you can see the different labels and the different cubic results over here, cubic numbers basically. So that's for that. And then basically just you also then plotting the first 5,000 cubic numbers. All I did basically is just made like a small modification to that, so I can comment this out. So essentially just setting a range here from 1 to 5,000 over here, and just using that same function here. And then that's basically just changes the range essentially. So instead of it being from 1 to 5, it will be from 1 throughout to 5,000. So now it will be larger numbers that we're working with, or larger cubic numbers, because now it loops through all of the numbers between 1 and 5,000. So you can see now the final result here of the scatter graph. So then moving on, here basically just applying a color map to your cube's plot. So in order to do that, still the same code, but the only difference now is this line of code here. CMap equals plt.cm and then the name of the color. So basically this just creates a color map. So essentially it's like on the line the different colors changing according to the values increasing. Basically that's what a color map does. So it just enters the PLT and then accesses the color map module, and then it sets it to this default color Viridis. So when you see here, basically the colors changing as the values go up, essentially. So that's what color mapping does. Then anything you want to add on that, bro? Aiden?
Not really.
Okay.
I mean, you covered the color maps pretty well. Maybe explain. I can't remember if you explained how the figure and subplots work. Figure and axe.
Yeah. So from my understanding, right, fig represents the figure. So basically like the figure for the graph. So like
the whole graph.
The whole graph essentially. Then x represents the axis, right? So like we have x values and y values. Those represent the two axes, right? So you have like your x here, basically. This y-axis and then the x-axis over here, right? So that's what that represents. Then plt.subplots, like, because you know plt is plot lib, so we're accessing like the module plot lib, right? And using that, we're calling the subplots method, which basically creates the whole graph, essentially.
Yeah.
Get what I'm saying? So
that's your init function effectively for making a graph.
Yeah, I didn't even see it like that. So yeah, basically, that's what creates the graph, automatically. And then
yeah.
Did you want to say something on that?
No. That's essentially what it is.
Okay. Yeah.
Sorry, I sometimes just start speaking out loud and don't realize it. Sorry.
No, it's all good, man. It's all good. Then I explained this x values. Basically, this contains the x values. This parameter contains the y values, right? And then here, basically with this, I'm not quite sure. C equals y values.
So your C equals y values is to do with your color map. So basically, C is the values. Basically, what values you want to assign the color map to. So basically, it's you can assign it to any kind of variable, but you obviously want it to align with your your increase in y in this case, at least.
Yeah. I mean that's why the colors change as the values go up.
Yeah. That's exactly what it is. Yeah. So you'll assign C to C different things depending on different different things you want to do. So like if you want to make a heat map, you have to do like an average between the X and Y values. It's a weird thing, but yeah.
Okay, I see. Yeah, makes sense. And then here, just setting the title and the label. Yeah, discuss that. So that's for that for like the creating the color map. Then moving on. So over here, yeah, this is when we're gonna import the random walk class from the random walk module. So modify rw visual.py by replacing x_scatter with x.plot, right? To simulate the path of a pollen grain on the surface of a drop of water. Pass in the rw.x values and the y values. So those values come from the random walk module, and include a line width argument and use 5,000 instead of 50,000 points to keep the plot from being too busy. So yeah, like we basically like importing this random walk class from random walk module, and over here creating this instance. At first it was set to 50,000, yeah, right? But now we set it to 5,000. So yeah, just to keep the plot from being too busy in a sense. Yeah.
It takes too long to load if it's like 50,000.
Oh yeah, that too. Yeah, take whatever.
Yeah, did you try and load 50,000?
No. Let me see. Let's try that.
Yep. It's gonna take like a minute.
Oh, okay.
Oh wow.
No, it's quick.
Oh no,
I'm
getting confused.
You know what this does actually? It basically.
I'm getting confused now, Robin.
Yeah.
Yeah. No, I was getting confused because I forgot to save my random walk thing and nothing was working for like 20 minutes earlier.
Oh, really? So you thought that was the reason? Oh.
Yeah.
Yeah. So it's like it keeps the plot from being too busy, basically. Like if you let's set it back to 5,000 and see. So. Oh, dude. So like. Yeah, this is how it looks now. Like I don't know how else to describe it, you know. But yeah.
Yeah, it's just showing the pathing.
Yeah, the pathing is different now. So.
Yeah.
And then here you call the full walk method. I'm gonna discuss the random walk module after this. Then sorry, hold on. Yeah, so here we're just using the style classic and then figure axis and then just calling the subplots method and then setting the figure size to 10 by 6 over here. So that will be the size of the figure basically. And then here the difference now is at first it was x.scatter, right? But you're changing it to x.plot to make a line graph. So plot means a line graph basically, instead of a scatter plot. So within here we have the x values from the random walk module, and then the y values as well. And then we set the line width to 1. So the line width on the graph will be set to 1, and then the color is set to blue, as you can see here. And then basically this creates the starting point and the end point for on the graph. So you can see here you have a starting point over here, which is this green dot, and then the end point here, which is the red one. So in order to have that, we do that by calling the scatter method. Um, and basically here is setting the start point over here and assigns the color green to it, and then like the size as well, and then the label which is start. So you can see here the label start, and then the start of the walk is basically here, and then this is for the end over here. Now I'm still trying to understand this, right? Because I know this axis is the end of the list, correct? So the end of like the x values list. So like, because you know the x values obviously declared here.
Yeah.
So the end of the
What don't you get about it?
It's I'm just trying to wrap my head around
So the actual indexing. So all it's doing is
I know that
yeah. So all it's
it
doing
goes to the end. Minus one goes to the end of the list, right?
Yeah.
So if it's going to the end of the list, then whatever, because at first it was set to 0, yeah. But whatever calculation happens here, whatever is at the end of the list, will be the end of the walk, basically. Correct?
Yeah.
Okay.
Yeah.
That's what I was trying to understand.
Yeah, so all it's doing is, remember, it's appending the new values to the end of the list each time.
Yeah.
And all that's doing is checking the last, what the last value that was added to the end of the list is, and then adding that scatter plot there. That's all it's doing.
Okay, that makes sense. I see. Then it does the same for the y values as well. Then
yeah. So yeah, that's it's. Remember, when you're doing your scatter or any plotting on a two-dimensional graph, you need an x and a y value.
Yeah, always. Yeah, makes sense. Because they correspond as well.
Yeah.
So then, then it sets it to red. So like you can see in the graph here, it's set to red.
So if you click that a magnifying glass, you can zoom in on it, like you can draw a rectangle over it, and you can zoom in on it.
Like
drag.
Sorry?
Yeah, click and drag over it. Click and drag over it.
Like, what do you mean? Like this? Oh, yeah. That's pretty cool. I didn't even...
Yeah.
That's pretty cool.
Yeah.
Okay.
It's good for presentations if you're going to become a data analyst.
Yeah, data analysis is a whole different game. But
yeah.
But that's that's using the scatter to set the end and start point, right? Then here basically removes the axis, right? So like here you can see it doesn't show like the values for the y-axis and the x-axis.
Yeah.
That's because this is set to.
Oh, I didn't.
Yeah.
Yeah, I didn't say why it was showing up on mine. I removed that because I thought it looked weird.
Oh yeah, but this
felt like
just sets it to false. Or you could just remove the whole thing anyway. So.
Yeah.
Yeah, and then.
You can also Anyway.
PLT.legend basically shows the plot, right? So, no, PLT.show displays the plot. I'm still trying to, I still didn't figure out what this means.
This legend, so go to your thing. Yeah, it's that. Yeah.
It shows the labels. Yeah. So this shows the labels, and then, and then this just shows the whole graph. And then...
So anything with the label will show up there.
Yeah, anything with the label,
So if you gave your actual walk label a label, it would show up on that thing.
Oh, it will pop up there on the corner.
Yeah.
Here you're just prompting the user by asking them if they want to make another walk, right? So Like, yeah, it's just like when you choose, it should be
You have to
popping
exit
up.
it.
Yeah,
You have to not there, close the actual matplotlib file
yeah,
window,
of course.
because that ends the program. And now you got it. So run the program again. Cool. Now close that window.
Oh yes, then it shows yeah. Then
Yeah,
like
because that's ending the program.
yeah, then if you select yes, it'll show another one. Okay, makes sense.
Yeah.
Right. Okay, yeah, then that's that. Yeah, just changing this to x.plot to make a line graph, and changing this value as well to make it less busy and stuff. Then like here for the class, well, for this module random walk, so it's basically like the functionality behind everything. Alright, so we basically just refactoring the module so the code is more readable and more understandable, right? So yeah, in order to do that, we'll create. Wait, no. Firstly, with this, right? Before we get there, um, here something like interesting is like when you move -1, right? Because -1 represents left,
Yeah.
and then 1 represents right. So when you move -1, like you won't move to the left at all in the walk. It will just like the line graph will move to the right essentially, right? So that's what happens when you remove this.
Yeah.
And
that's only allowing for upward mobility and no downward mobility.
Yeah.
So run that, and then just give it a second to load. Oh, you can't run. Remember, this is not being called. You have to run it.
Let me run this now, and then let's see how.
Did you save the other file?
Yeah, it's saved.
Cool.
Saved. Okay, yeah. Now it moves in one direction. Upwardly, yeah.
Into the right.
Yeah. So that's because we moved the -1, basically.
Yeah.
So, like, let me set this back.
Yeah, like in real life, if you, like to find those kinds of things, if you just remove the -1 in X, you'd have a linear, like a timeline graph. So that's what it would look like if you're looking at like stock prices over a certain time period,
or
like
so just
your
set
elevation,
it to 1.
distance in like Earth.
Yeah, because that's linear. Yeah, I see. And then, then moving on to like refactoring this random walk module, right? So basically creating a new method called a get step to determine the direction and distance for each step, and then calculating the step. So making the calculations within like the get step method, right? And then basically ending off with making 2 calls to get step. So for like the X step and the Y step, we'll make calls by calling get step, right? So that's how we'll refactor it. So still pretty much the same code, but just with a new method over here, get step. So here's basically what I did. So like at first you can see here a full walk method, right? It has all these calculations and basically has 2 sets of calculations for the X step and the y step, and the direction and distance for the x values, direction and distance for the y values, right? And yeah, it still works, but in order to just make the code more simple, right, create the get step method, and we just have one set of calculations here, and basically just having direction, right, and using the random choice generator. So because we imported choice from random, that basically chooses between 1 and -1 as direction, so it will be randomized, right? And then for the distance, we have our choice, and then it will choose um, any value within this list for distance. Then to calculate the step, we take direction, right, which is randomized, and then distance as well, and you multiply that, and then you'll get your step, right? But in order to get the step for the x value and the y value, right, so we have to call the get step method twice. So over here within this for walk method, we have x step, and then using self we call get step. That will get the value for for x step basically, and then essentially the same thing for y step also. So just calling get step twice basically, and yeah, it's pretty much the same thing as this random walk method, but just refactored and created a new method over here for the calculation specifically. And if I can explain, yeah, this while loop here, everything runs according to this condition here. So while len the self.x values, as long as the x values is less than the number of points which is set here as a default value 5,000, then all of this will run basically. So over here we have if x step is equal to 0 and y step is equal to 0, so it will basically just to continue. So am I right in saying that it will just skip this if it's 0 basically? Because if it's 0, then
Yeah.
it can't be displayed on the graph essentially.
Yeah, it would just be the same place.
Yeah, it'll just be in the same place because there's no movements. The steps are not, they haven't changed.
Yeah, and due to the nature of like the choice function, that it's unlikely, but it's very possible that it might just not move.
Oh yeah, definitely. So then to calculate the new position, right, you have this x variable, y variable, right, and then basically indexing x values and getting the last value in x values, right, in the x values list, right, and of course that's going to be appended over here, but getting that last value and then adding the x step, so basically the new value for x step to that last value in x values, right, and then the same for y values as well, so that will create the new position on the graph. And then basically just appending x to the x values essentially, and then appending y to the y values, and then that's how, am I right in saying that's how the new values are displayed basically?
Yeah, essentially.
Yeah. And then I discussed this basically just calling the two methods. I mean, calling the method twice for x step and y step. And then, yeah, then this is the get step method with the calculation, basically. So it's still gonna work because it's still the same functionality, but it's just refactoring the whole thing. Wait. Let's see. Running it from there again. So yeah, still shows the graph as it is, basically. Alright, cool. So I think that's pretty much it. Is anything else we can add?
Not really. Like you've covered pretty much everything. Yeah, I think that was a good one.
Alright, cool. Thanks, man. Thanks
If
for
you
watching.
don't understand,
I think all the questions I asked were the main things I didn't understand. So
yeah,
that's pretty
I
much
mean,
it, man. Like,
yeah, it's making a graph, X and Y values.
yeah.
If you play Minecraft, you know what it is.
I should know, bro, because I've been playing that. But yeah, anyway.
Yeah.
Let me end.